Hello everyone, my name is Varun. Today we are going to discuss about F5 LTM SSL Packet Capture. So SSL stands for Secure Socket Layer. It's a standard technology for keeping an internet connection secure and safeguarding any sensitive data that is being sent between two systems. It was designed to support protocols such as FTP, HTTP, and Telnet. So what SSL does is it encrypts the communication between the client and server so that the communication is safe and no one can read it. If we talk about hypertext transfer protocol secure, it is an application specific implementation that is combination of hypertext transfer protocol with SSL oblique TSL, TLS. HTTPS is used to provide encrypted communication and secure identification of a server so that no middleman can intercept the data easily. So HTTPS is the combination of HTTP with SSL. So so when HTTP was used, the communication between client and server is in clear text, whereas with HTTPS, the SSL certificate is used to encrypt the communication between the client and server so that no middleman can read the data. So if we talk about the SSL communication, how it works is, let's say you have a client, right? This client is trying to access a server, right? So once the client will try to access the server will send a certificate to the client. Client server will send a certificate to the client. This certificate will be having a public key of the server. After receiving the certificate, client will create a session key for this session and will send this session key to the server that would be encrypted using the public key that server has sent to the client. So the session key is encrypted using the public key. Okay. Now once this communication is done, once the session key has been established and has shared with the server, now whatever data client will send to the server, that would be encrypted using the session key so that no middleman can read the data. So this is how SSL works. So if we talk about SSL handshake, SSL handshake is done in below steps. First, client send a hello message to the server that contains the supported SSL option that clients support. Then server responds back with a server hello, selecting the SSL option. So in the very first step, client send a hello message to the server which contains the supported option that client supports. Then server sends a hello message by selecting the SSL option that server wants to use. Then server sends a certificate to the client. Then once this is done, server completes the part of this negotiation. Okay, now, as of now the server has sent the public key certificate to the client. Now what client does is client send an encrypted session key to use for the communication. So once the client has the public key, it creates a session key and send it to the server after encrypting it by the public key that server provided. Then client initiate the negotiated option for all future messages. Initializes the negotiated option. So now client initializes the negotiated option for all future messages it will send by using a message change cipher spec. Then client finishes this client finishes this negotiation and client notifies the server to verify the negotiated option for this session. After this, server initializes the negotiated option for all future messages it will send using change cipher spec. Then server notifies the client to verify the negotiated option for the session using the finish message. Now after this, the actual application data flows. So this is how this negotiation, SSL negotiation, looks in Wireshark. So let's say you have a client 192.168.31.1 trying to communicate to the server 192.168.31.10. First of all, client send a client hello to the server. Server acknowledge that message. Then the server sent the server hello with certificate and server key exchange, and then the server hello is done. Then client sends a key exchange and the change cipher spec messages. Then server acknowledges it. Then server sends the change cipher spec encrypted handshake messages. Then the actual application data is sent. So in our lab topology, we will be doing this practical. We will be having a client that would send the traffic to F5, and F5 will send the traffic to the server, backend server. So the client IP is 192.168.31.1. The virtual server IP is on which client will send the traffic is 192.168.31.10. The F5 self IP is 192.168.31.2, and the backend server IP is 192.168.31.30. So the client IP is 192.168.31.1. Client will send the data to the virtual server IP, that is 192.168.31.10. Then F5 will send the data to backend server using the self IP, that is 192.168.31.2, and the destination would be 192.168.31.30. So initial request, the source would be 192.168.31.1, destination would be 31.10. Once F5 receives it, it will perform a SNet, source net, and convert this 31.1 IP to the self IP of F5, that is 31.2, and the destination IP to the actual server IP. So there will be two sessions, one session between the client and the F5, and another session between the F5 and the server. So first of all, they will create a TCP session. Client will send a SYN message to the server. Server will reply with a SYN ACK, sorry, F5 in this case, and then server will acknowledge it. Similarly, there will be one session between F5 and the backend server. F5 will send a SYN message to the backend server. Backend server will reply with a SYN ACK, and then F5 will acknowledge the session. Once this TCP session is done, this is a TCP session. Once this TCP session is done, they will start a TLS handshake. So with TLS handshake, again there will be two handshake sessions, one between this and one between this. So client will start the TLS handshake by doing client hello, and then server will respond with server hello that we discussed previously. Similarly, there will be one TLS session between the F5 and the backend server. It will send a hello, client hello, then this will reply with a server hello, then server will send a certificate. So then this will finish this negotiation, server will finish the negotiation, like the similar way that we discussed here. Client hello, server hello, certificate, then server hello done. Then client will send a client key exchange, then it will send a change cipher spec, then it will send a finish message, then server will send the change cipher spec, finish, then actual application data will flow. So this is what we will be doing in our lab today. So let me just access the load balancer first. Our load balancer management IP is 192.168.11.10. let me log into this. Okay, so this is the F5. So we have our virtual server configured. So the name of the virtual server is web server, and the IP address of the virtual server is 192.168.31.10, and this virtual server is listening at port 443, and we have a client SSL profile deployed which has the certificate, and this translation is set to the auto map. So whenever the request will be coming from the client, the source IP will be changed to the self IP of the F5, that is 192.168.31.2. So whenever a client try to access the virtual server 192.168.31.10, once that request will arrive the F5 will do the source net and change the client IP to 192.168.31.2, and the destination IP to the actual server IP, that is 192.168.31.30. So let's start the packet capture. So in order to perform the packet capture, we'll first configure the packet capture. The command would be minimize this. The command would be tcp dump -ni. So we will be taking it on all the F5 interfaces. So we'll put 0.0. Okay. Then in order to take a packet capture file, Wireshark file, we'll run this command -w. We'll save the file in WAR folder under temp by name of log4.pcap. Okay, and we will be running the packet capture on the virtual server IP, that is 192.168.31.10, and we'll put -v. Now the packet capture has been configured. As of now, 0 packet has been captured. So let's try to access the virtual server now. So this is the virtual server IP 192.168.31.10. So we tried to access it using HTTPS. Now it came up with a warning that the certificate is not trusted. So we can simply proceed with this site. Now see, this communication is secured with this certificate. So basically this is an SSL communication that is secured using the certificate, and we also received some traffic in the packet capture. So I'll stop this packet capture, and we will go to the we need to go to the jump host, and then we'll copy this captured file in our local system from F5. Now we'll access the load balancer using WinSCP. Now the file protocol would be SCP. Load balancer IP is 192.168.111.10, and the credentials So we are able to access the F5 from the WinSCP, and we have captured the log file under var and temp. So we'll go under this folder from WinSCP. So we have to go under var, under root. You will go under the var. Just type in v. Under var, go to the temp folder, and here we will be having a log4 file, this one. So we'll copy this to the desktop. I'll copy this to my local system to analyze it. So now we are going to open this captured file using the Wireshark. So this is the capture that we have. So see, this is our client IP 192.168.31.1, right? So if we go here, the client IP is 192.168.31.1. The virtual server IP is 192.168.31.10. The self IP is 192.168.31.2, and the backend server IP is 192.168.31.30. So as we discussed, first of all, there is a TCP handshake between the client and the virtual server IP. So client sent a SYN message, then the virtual server responded with a SYN, then the TCP session is completed. Right after the TCP session, the Tls session started. So client sends a client hello to the virtual server IP. Then virtual server IP responded with an acknowledgement to acknowledge this hello. Then the virtual server IP sent a server hello to the client. Then after the server hello, I think this is the previous communication, so we can let's consider this one. This is the separate session. Now if we go here, see, client send a client hello, right? Server send this server hello with the change cipher spec to the client. And let's do one thing. We have to just to isolate it. Let's follow the TLS stream here. Okay, not this one. Actually, this packet capture is for the resume session, as I already opened the server. So either we can clear the cache and again try to access the server, so the new session will be created, or I have one session or one log file previously saved that has the new session. So if I go to this file, so see, this is the client and this is the F5 virtual server IP. So client send a SYN message to the virtual server responded with a SYN, then the client acknowledges the session. Here the TCP handshake is completed. Now TLS handshake started. Client send and client hello to the server responded with a server hello and send a certificate to the client, and server hello is done. After receiving the certificate, certificate, client just a minute, if we do this, let's follow this TS stream. So if we consider this flow, client send a client hello, server responded with a server hello, certificate and the server key exchange, and the server hello is done. Then client responded with a client key exchange and the change cipher spec. Then the server acknowledged us, then the server responded with the change cipher spec, then the application data is flown. So if we follow this TLS stream, it is here. So see, first client hello, then an acknowledgement from the server, that is the F5 virtual server IP, then the server hello with a certificate key exchange, server hello done, then a client key exchange, change cipher spec from the client, then server acknowledge it, then server send the change cipher spec, encrypted handshake message, then the actual application data is there. So this is communication is between the client and the F5. Similar session would be created between F5 and the backend server. So if you just clear this filter, so this is our self IP of F5. So another session is created between F5 and the backend server. So F5 self IP sends a SYN to the backend server reply with a SYN, then this connection is established, then the TLS session is established between the F5 self IP and the backend server IP. So this is the F5 self IP sends in client hello to the actual server, the backend server. The backend server replied with a server hello and provided the certificate. Then the F5 as a client send a client key exchange and the change cipher spec. Then the backend servers as a server send the change cipher spec. Then this is the acknowledgement, then actual application data is shown. So this is how TLS handshake works. So now in order to see, now this is fine, right? But see this traffic, if we talk about the application data, we can't read this application data, right? Because this is encrypted now. Once the TLS handshake is done, right, the client key exchange is done, both client and the server has the session key, right? So whatever communication it does is it is encrypted. So that is why we are not able to read this application data. It is encrypted using the TLS. Now if you want to read what exactly is inside this application data, you have to decrypt it, the HTTPS traffic to HTTP. So in order to do this, you have to follow these steps. You have to create an IRUL in the F5. This is the IRUL, one for the client SSL Handshake, another one for the server SSL Handshake, right? Then you have to attach this to the virtual IP where you want to perform the packet capture. Then run the packet capture again. Then pull out the SSL key. So see, now in order to decrypt this traffic, right, we will be taking out the key that that client and the server are using to encrypt the data so that we can decrypt it. So this is the command to take out the key. So we already have the IRUL applied to this virtual server. So we go to this virtual server, right? So we have the IRUL applied that is required to decrypt the SSL session. So if we go to this IRUL, we already have the IRUL applied for client SSL handshake and server SSL handshake. Now in order to decrypt our packet capture, what we have to do is we have to take out the session key, right? So in order to do it, we have to run this command on the F5. So what it's gonna do is what IRUL does is it copied the session key in the LTM logs, right? Now we have to copy this LTM session key from LTM logs to one of the file, that is SSL key.pms. So we'll simply run this command F5. Okay, go to the F5 and run this command. Now there would be a key file in the var temp that contains the session key. So we have to go to the jump host, we have to refresh it. So it is under the, so we have saved it in var temp SSL keys, right? So we already are in var and temp, right? We already are in var temp folder. So it should have a file named as SSL key. So this is the file, right? It's created right now. So we'll copy this to the desktop now. we are going to copy this to our system. Now in order to decrypt the Wireshark traffic, we'll go to the Wireshark and go to the edit, go to preferences, then go to the protocols, go to Tls, okay, and it asks for the key RSA key, this one, right, master secret lock file name, right? So we'll browse this thing and we'll browse the file that we have recently copied. Hit OK. See, now the traffic has been decrypted. So previously the application data that was sent was encrypted using TLS. Now what we does is the key that client we copied the key that client and server were using to encrypt the data, and we decrypted the data using that key. Now that TLS is decrypted to HTTP, now we can see that the client is sent a GET request to the server, right? Previously we were not able to see it. So this is how you can decrypt the traffic. Hope this video was helpful. If you like this video, please subscribe to my channel and press the bell button. Thank you.